Hello everyone, how's it going? This is Jason from Stray Basilisk back again. Welcome to another live coding challenge stream. I've just noticed Ladrich is hosting us right now and just followed. Thanks very much, Ladrich. As always, we're going to wait a while for people to arrive before we really get stuck into the coding. But first, a kind of quick summary of what we're trying to do today. I thought it would be fun to try and make our own version of something like a Hearthstone style trading card. What I like about Hearthstone's cards is, you can probably see that just fine, is that they have these nice kind of effect going on. So they have some kind of glowy particly stuff, some kind of warping effects. They have like some shininess around here. We have these light shards, and each card has different stuff going on. So if we just flick through a few of these. Yeah, they managed to create some really nice varied cards. I mean, there's, I don't know how many hundreds or even thousands of Hearthstone cards there are now. But most of these are made in a combination of a few kind of basic effects, right? Like we have this scrolling texture moving across here. That's one kind of effect, it looks like. There's this kind of wavy distortion, noisy kind of thing going on. There's a whole bunch of them, basically. But they really feel alive, right? And really effective. If you're playing like a card game on the computer, you'd hope that they would take advantage of the fact that it's a video game and not a pen and paper thing. Hey, Creatix, welcome. How's it going? Yeah, so I kind of want to try my hand at making some things kind of like this. Maybe using some of the characters from Steamhounds, which is our main game project. So I've already Googled around a bit and I found this thing here. So again, this is a website we used before, I think, for the flocking simulation, but Open Game Art is a great place for all sorts of game assets. And just by searching for card up in here and clicking through a few pages there, I landed on this frame, which I think is quite nice and relatively on theme for Steamhounds. So I think what I'm going to do is just download this. So this is made by Cethiel. I'm not sure who they are. They have a Patreon over here people could check out. Oh, it looks like if you sign up to the Patreon, you can get really like high-res versions of these things. But they have put this up here on like a Creative Commons license, so this is something we're able to use here. So I'm just going to grab the zip, open this up, and we'll see what's inside. Well, looks like there's more than one. Okay, so these have been layered up. What I really want is, I just want the frame as like a single image, so let me look around to see if the other download had that. Okay, this should do what we need, and this is plenty high res for our purposes, I think. Okay, that's kind of annoying. Let me put it into our streaming folder here. So another departure from our normal pattern. I'm not using processing or P5 this time. I'm actually going to do this in Unity. The reason being that I kind of want to have some pseudo 3D stuff going on. So the way I kind of imagine this is that we're like looking down probably at a table, and we can like click to pick these cards up and maybe drag them and move them around and drop them back down again. I mean, there's going to be no real gameplay, but I'd like these to be like real kind of objects which feel a bit more alive and dynamic. And also a lot of these effects I think will depend on, I'd really like to have like some light glistening on these shiny bits, which, you know, depends on the angle which they're tilted at and stuff like that. So yeah, being able to move them around will again show off some of those more dynamic effects, I think. So, you know, I could probably just spec this image out. Okay, let's not do that. We already had it here. So I've got a basic, completely empty skeleton of a 3D Unity project here. So I'm just going to create an images directory in the asset folder. this is going to kind of be an overlay. I think I'm going to try also quickly just assembling the card in an image editor to begin with, so we have an idea of what the final thing is going to look like before we layer all the effects on and stuff. So I think I'm going to create just a background here. Now I have a few assets from SteamHounds which I could use to make this. I'm also leaking some previously unannounced or unreleased character artwork in this stream potentially, so consider that a bonus if you like. So here's the old classic engineer. We've all seen this guy before, he's showed up in other coding streams. What I like about this is there are so many obvious ways we could throw some effects on here, right? Like we've got smoke, obviously. We've got like these glowy, furnacey, do you call these pauldrons? Like these shoulder pieces and this chest piece. There's even some water down here. There's bits of metal we could make shiny and reflective. There's so much stuff we could do. I would say we could make his hair like wave in the wind, but he's using some high hold factor gel by the looks of it here, so I don't know if that's 100% appropriate. But yeah, this is a real obvious like first thing to try. So we have like this image of him here, which I could try and throw into a card. Let's kind of see what that looks like. Probably not quite that size. Yeah, maybe too big there. Let's scale him down. Maybe 50%. So I really like this asset. I'm not totally sure how the framing is going to look. Maybe that would work, right? That's kind of nice. I'll just get rid of the outside parts of him. Maybe throw a different background color on there. I don't know what's going to work. It's one of my favorite colors that it's not really going to be complementary. Let's go with grey, I suppose, to begin with. Yeah, any artist around? Anyone know color theory? What background color should I use? Tell you what, now I've got this here, I can use this colorize thing and kind of scroll through some hues here. Something kind of dark like that might work, right? Oh, blue. Yeah, I like that. Helps this kind of glowy shoulder stuff to pop out as well. Okay, this is a good possibility, I think. Yeah, I kind of like that as an option. So what I'll maybe do is first let's crop this down so there's no unnecessary stuff there. The card overlay is already exported, so Adobe Color. Let's do it. Let's go on a tangent. Check this out. I assume this is a website, right? Because I don't have like an Adobe subscription. So, okay, I've seen these kind of things before, right? Yeah, it will find you like complementary colors. So I guess he has like an orangey, like glowy color as one of his main colors. Yeah, so like a green or like this would kind of be complementary. I suppose the direct, yeah, complementary is the direct opposite color, right? So maybe this kind of thing. Yeah, that really does, that works as well. Okay, I'm happy with that for now. So first let's export this overlay now that that's cropped down. Then let's try taking our base card image here. It's going to be covered up, so it's kind of rough around the edges, but I think that should be fine. Okay, there is our guy. I suppose the next thing to do is to begin assembling this into an actual card type object in Unity. So, got these images in here. I kind of want to just throw these onto quads, so I'm going to create a quad here that matches the size of this. Nope, that matches the size of this whole image here, so it's 550 by 766. It's probably massive, right? Doesn't exactly matter what the scale factor is, I don't think. Then we could make some materials for this. So create material for the card overlay. Okay, and I'm just gonna... Ooh, don't know what's going on there. So I'm just gonna take like a standard, yeah, I suppose like a standard. Ultimately we're gonna... Okay, this is gonna be mostly like writing shader code. I feel like that's what this is gonna boil down to. So I think I may, to begin with, just use like an unlit textured or textured with transparency supported thing here. So I'll put the overlay in. Should make sure this image is imported with transparency. And then let's throw our move the inspector to the left. Yeah, I think yes. Let's do that. Good shout. Yeah, that's probably wise. So I put this in the wrong place, so I'm going to move this up into materials. So Creatix, have you ever played with Unity at all? You do C# stuff, right? Or am I mistaken there? Throw our material on there. It's probably backwards to us. Should maybe just move the camera around here. Okay. There's a nice card kind of floating around in 3D space. I'll make another material. I find when I copy a material, like it doesn't copy any of the properties, which is kind of really annoying. Again, I'm just going to use like the unlit thing here since we're building our own shader for this. There's our engineer. Okay, yeah, fair play. I'm sure, yeah, maybe I misremembered that. More of a JavaScript node, PHP guy. Okay. So there's our card overlay. This card content, shall we? Cool. Let's make sure that this is slightly behind. Okay. Now I'm going to kind of group these up to their own object here. Gonna make these zeroed relative to their parent. Probably done this in a silly order. Again, I just need to make sure that body is like slightly behind. I could probably do this with sorting layers, but this is fine for now. And now I have a card which I can move around. Cool. So I think I'm going to work first on the interaction and movement of the cards, and then we'll get down into the visual effects and shader stuff a bit later on maybe. So for that purpose I have another sort of background image here. Again, this is something you'll eventually see in Seamhounds. It's kind of supposed to be a background, so it's pre-blurred here, but this will be featured in an upcoming patch. But I'm just going to export this into our Unity project. Oh, this really annoys me. I end up... So when you create a new project in something, it asks you for the folder name, and you're never sure whether it's going to make a subdirectory itself or not. So the number of times I end up with these pointlessly nested subdirectories. It is the worst. The only thing is using processing, if you do that, if you then move or rename the folder, the editor then detects that all the content of the project you were looking at is gone and just recreates it from the stuff from the tabs and stuff you have open. So then you have two copies there. Yeah, that kind of gets on my nerves slightly. Okay, I feel like we don't need the light stuff going on here, since we're gonna kind of handle the lighting probably. Yeah, I mean, we could do some of the built-in lighting stuff, but I feel like a lot of the Hearthstone stuff, it's all very cartoony and bright, and yeah, I don't know if we need to use Unity's inbuilt lighting. They can more or less be full saturation like this, and we'll just throw some nice glittery stuff on top. So let me the backdrop in here. Could probably use a sprite for this, but so used to the inspector being over here, it's throwing me for a loop. Oh, that's weird. Not sure what happened there. Okay, there we go. Let's kind of get our camera positioned. Just try with an orthographic projection for now. So I believe it should be half the height in order to get it clipped as we like. Cool. I can move the backdrop way back behind our cards. Oh, where's my camera? Okay, I need the far plane to be higher so that it's got more of a depth. Okay, getting our basic composition going. I think I want the card to be bit smaller here. Yeah, orthographic perspective. Yeah, okay, let's draw a diagram because this is kind of fun. So, okay, perspective projection. I almost drew on my tablet with a real pen there. That would have been ill-advised. Okay, so if you have a camera, then the normal way a camera works, just like the way actual perspective and like an eye works, is it has a kind of field of view, right, like this. Meaning that if there's some object that's like here, then it's a... I shouldn't draw that different color. Then if there's some object like here, then its apparent size is kind of projected back down onto this lens, right? So it will take up like half of the lens. If you look at the kind of screen as it gets rendered, we'd see something like that. But if something is the same size but is like further away, so like over here, now it's only like, you know, about a third of the size of our window, so now it appears smaller. It's in the distance, right? So it appears kind of like that. So that's a normal perspective projection. An orthographic projection is kind of like the sort of projection you'd get in like a technical drawing, I suppose, like an architectural diagram. What it means is it's kind of physically impossible because it's sort of like this. Oh. Ah. Yeah, it's kind of like just straight lines coming out, so that if you have an object here, it looks just as big as an object, same size but further away. Yeah, so you don't get like, you know, if you're looking at a wall, it doesn't like recede into the distance like a real one would. Yeah. So it's nice for 2D stuff that's just like gooey, you know, gooey type stuff. You can almost imagine it. Like they have depth because you want them to be sorted in a different order, or like rendered one on top of the other. But there's not like foreshortening or real like perspective effects. Yeah. So, you know, some games have this kind of style. Okay, we've got some incoming spam. Hang on, let me kick these people out. I take it as a good sign that we have spammers. It means we're somebody worth spamming, I suppose. I don't know. Number one, and number two. There we go. Okay, sorted. Yeah, so that's orthographic projection. It has a very characteristic kind of look to it. Yeah, like this kind of thing, right? Like there's no perspective going on. Yeah, and in this case it means I can, you know, if we look at our scene, then our background, even if I push it like further away, it's not like, okay, bad example. If I push it further away, it doesn't like shrink and get bigger in terms of like the camera's view of things, although I still need to make sure it's within the kind of range of the camera. There we go. Yes, that's normally a kind of handy way to go about things. Yeah, whereas with perspective, right, we see that this thing's further away so that it appears smaller. Yeah. So if I take my card, I can now shrink this thing down a bit. Play around with the cool. Seems to make sense. And now what I'd like to be able to do is to like pick up and drag this thing around. I think that would be kind of fun. So the first thing to do is probably attach. So in Unity, the way we're going to detect that we've sort of clicked this thing is using like a raycast and like a physics collider of some kind. So I imagine it has a tendency to like automatically add colliders to pretty much everything. So I think I'm going to remove it from these because we kind of got this structure where we have our card and then it has like two objects inside of it. I don't want these both to have like physics colliders and stuff because it's kind of unnecessary. And what I'll probably do instead is add like a box collider to this. Then we can set the scale of it. That's appropriate, and now we can think about attaching a script to this thing so that we can detect the click and then start to like drag the thing around. So I've got a blank script here, which I don't need. In fact, I think I can just go in here and add new script like this. Yeah, cool. Let's call this draggable. Ah, where did it put that? Not where I wanted it to be. Something's causing this to kind of go really slow. Okay, there we go. Now, finally on a stream I get to make something with a proper IDE, which is going to be a treat. So basically the way we want to do this is like to have some kind of a state, like is this thing being dragged right now or not? If it's not, we're going to check for if the mouse button is pressed, and then do some kind of like physicsy raycast to detect that the mouse is like over this particular object. Cool. I can also do, this is a luxury as well, which I didn't have in the other editor. Cool. There we go. Probably don't need this output. Or this. Probably should have just dragged these down. Ah. Cool. So what's the logic going to be here? It's like if we're... I could think about an enum and doing a more of a state machine, but it's literally going to be being dragged or not. There's no gameplay we're doing, it's purely like the cosmetic thing of dragging it, so this is probably all we need. So okay, so we have this handy function which will, I don't know if you can read this, returns true during the frame the user pressed the given mouse button. So this will like fire off once, which is probably what we want, right? So is this a function or? Yeah. We probably have to say like an index for the mouse button. I assume 0 is left. Great documentation there. I could check the real documentation, I suppose. So then we want to kind of do a raycast. And if people aren't familiar with a raycast, it kind of relates back to this stuff with these camera perspectives actually. All a raycast is going to do. So we've got our card now in the scene. You know, maybe it's kind of rotated slightly, maybe it's like that. Then a raycast is going to send out a kind of virtual. Oh, thank you, awesome. Much appreciated. So a raycast is going to send out like a virtual ray from a certain sort of point on the screen and detect, have we hit an object or not? I think more precisely it will kind of give us like the first object we hit, so if there's another card behind it, that won't get triggered. And this is essentially a proxy for have we clicked on the card. You know, if the screen looks like this with the card, then it will take into account all the perspective and stuff, and it will tell us whether the kind of mouse position is over that card or not. Obviously this is actually much easier with orthographic projection, and we probably wouldn't even need to use any physicsy built-in stuff to do it, because the coordinates of something in the world like much more directly correspond to coordinates on the screen when we don't have this annoying perspective stuff going on. Yeah, so this is the same way that like shooter games will tell you whether like your gun has hit somebody and that kind of stuff. It's all the same basic technique. I could try and remember the exact syntax of this. I mean, I have IntelliSense, so maybe this will work. Dot raycast. Okay, that's looking promising. So it looks like we need to pass in a ray or not. We can probably pass in that. I wonder if there's a... Yeah, like an origin, a direction, and a range. I think there's a way to... Aha! Unity's full of like convenience functions, so I can actually just take a screen coordinate and it will create a corresponding ray in like 3D space. Yeah, pesky physics, it makes the world far too complicated. So I can probably do something like this. Nice. Mouse ray. What else do we want here? Max distance, so... Okay, it looks like it's going to return a boolean whether it hit something, and then it's going to use like an out parameter to give us the exact details of that. So if people aren't familiar with out parameters, it's kind of a way of returning a value. Like you pass in a variable and it uses it to return something back to you, which is kind of funky, but no, works just fine. I think there's some syntactical sugar for doing this more conveniently. So can I just say... Okay, yeah, I think this is equivalent to doing something like that. I kind of prefer this because I like to be able to scan this and see that I've like declared a variable like explicitly. So we can just say if we raycasted that, for now, let's just log something. We should probably set this to true. Yeah, I think this will do what we want. So you know, using this thing which is only true for one frame means we won't be able to like drag the mouse over and pick something up as we like fly by it, which could get really weird and messy. So as it recompiles all of that stuff. Kind of want the console. Don't be full screen, please. So I click here, we get nothing. Oh, something happened. Oh, so one thing is we never set that value to false, which I may as well do now. Let's reorganize this slightly. So that our two kind of states are a bit more kind of delineated there. Yes, I am just going to nest some if statements here. You know, it's kind of hitting my limit of nesting comfortability. So this will mean the mouse has been released. Let's clear this, so seems like it's firing wherever I'm clicking here. So I'm doing something not quite right with the raycast here. Oh, I know what's happening. What's happening is I'm checking the raycast, but I'm not checking that it's actually against myself, right? This is going to return true if the ray hits anything, and almost certainly our backdrop also has like a collider, which means that this is going to be catching all of those rays. So if I remove this, you should see that stop happening. Okay, cool. That appears to be behaving as we could expect. You might be able to see the timestamps are being updated here. If I turn off collapse, it might be a bit clearer. So I can move the mouse around, and then when I release, it stops. Cool. So this will work just fine if we only had one card. We actually kind of need to check that. I'm going to reorganize this slightly because so we just fail out of this early all the time. So this array will hopefully tell us what actual object was hit. So it gives us the collider which was hit, and then we can look at the game object of the collider, see if it's the same as our own game object, and that should work out just fine. I'm going to again make that like a bailout condition. Kind of what we're doing there, and in that case we can begin the drag. Cool. Okay. So if we're going to make this drag happen, we kind of need to figure out if we want the drag to actually start moving us around. Then, okay, let's consider this situation. So we have our screen, we have our card inside that. So when we pick this thing up, the mouse could be at any position within this card, right? So it could be here, it could be here. But probably what we want to do is if the mouse moves like to the right, then we want to end up as if we're grabbing it by the same kind of spot. Wow, is my head tilted? That's way off. Anyway, yeah. So what we probably want to measure is, we want to remember the point when the drag initially happens, and then we want to figure out, okay, while we're being dragged, we're going to kind of just position ourselves relative to that kind of offset. There's two ways of doing this actually. So one way is to just each frame consider, okay, how far has the mouse moved this frame? It's moved like this, so then we're going to move ourselves like correspondingly. Then the mouse moves again, and we can kind of do correspondingly, and that would work. But I generally don't like things which are where the state is updated by like continually accumulating little deltas. When you can do it just by remembering, oh, what was the very start position of the drag and what's the position now, and that will straight away tell us where we should be positioned. I feel like that's just cleaner and kind of more elegant to me. I'm sure it's technically less susceptible to like errors accumulating over time, but that's kind of not probably a practical issue at all. But yeah, so I think what I'm going to do is remember my position when the drag started, remember the mouse's position when the drag started, and then I can kind of work out how that's changed. So when we start the drag, transport position, okay. Let's kind of rewire this slightly, so okay. So the drag or the drag mouse offset, if you like, is going to be the mouse position subtracted from the start position of the mouse. So clear off some of this stuff. So that offset is just going to be this kind of vector here, right? This line from where the mouse was to where the mouse now is. And then our position, we just need to take our original position when the drag started and apply that to it. And it'll just shift us accordingly, the same amount as the mouse. Luckily, because of the perspective thing, the mouse position should kind of correspond to the world space position. But if not, we may need to do a bit of conversion if the perspective is not orthographic and it's not like sized to be the same number of pixels as like the world units and stuff. So our new position should be our start position plus whatever the mouse's offset is. Cool. Will this just work? Apparently not. Let's see what's going on here. Did I save this? Most likely not. Okay, there's clearly a scale factor going on, but this is moving in the same direction. It's just not quite. You can see my mouse is not staying over the same like bit of the card. So I need to figure out kind of the world position of the mouse, which I can probably do from I mean, this kind of gives us it, right? It gives us like the origin position. I'm sure there's a better way to do this. Like, sure there's like a screen to world like scale factor somewhere. But basically what I need is like the origin of the ray. And then I can do something very similar where do this, and I think that will handle that transformation for us. Yeah, Unity is also quite nice in that it recompiles all your scripts kind of live, so I put my mouse like, I don't know, right on the tip of his little beard there, and then jiggle this around a whole bunch. Okay, we're still on track there. Awesome, so that kind of works. First of all, let's create another card to make sure nothing weird's going on with like the raycast or double counting stuff. Okay, they're at exactly the same position, so they're intersecting in a slightly odd way. But that's not a huge issue. Now, what I kind of like to do is make the movement a bit more flowy and kind of cool. Like often what you see in these games is as I move it to the right, the card will kind of like rotate. So if I move it this way, it kind of moves like this, like waving side to side. So a bit of rotation gets thrown in accordance with like the speed you're moving it around. And then it kind of settles back. So I think that'd be a cool thing to apply here. I also think it might be nice if when I clicked it, he kind of moved closer slightly, so they'd be on top of the other cards, and then maybe when I release, like drop back down to their previous depth. Maybe that doesn't do so much since I am using orthographic projection here, but let's see. Yeah, let's get like the up, down, side to side, like slightly curvy movement stuff going on. So I think the way I'll do this is kind of have like a rotation offset, which I'm going to modulate according to the speed. Yeah. I think also what I want to do is figure out how much I've moved like this frame. So I'll just sort of save off our old position here, because I kind of want to figure it out here. Right, so now I know how much I've moved this frame, and then taking into account how much I've moved and probably how much time has passed, I'm going to like just modify the rotation slightly. I probably want some like parameters for this. Let's make these private, but maybe some public stuff for throw a number in there arbitrarily for now. Let's throw some magic numbers in there for now. The other nice thing about Unity is we can tweak this while it's running, so I feel like what I want to do is, okay, so let's think about this in terms of axes and stuff are at play. So we have our card like this, and if we're moving to the right, then what I kind of want to do is to like rotate it like this way, so that it will kind of be not the greatest drawing, but you know, slightly kind of offset like that. So think about which axis is this. It's rotating around this axis here, which probably depends on how we've arranged stuff, like if it's down on the ground or not. But this is going to be the y-axis. So yeah, we're going to rotate it around the y-axis, and if it's moving to the right, yeah. So let's just throw it in for now. So let's consider how much we've moved in the x-axis, how much time has passed. We want to add that onto the previous rotation. But we also want to clamp this so it doesn't get beyond our maximum. Okay, we'll do the other axis afterwards. I can just say, so rotation will be a quaternion probably, which I'm not going to get into in this stream, but we have some local Euler angles, which should probably work for us here. Okay. These in degrees. Let's have a look. Okay, yeah, these are degrees. So I'm way off. I was thinking in radians, so we need, I don't know, like something like that. So maybe have it rotate up to 20 degrees. We scale by the number of pixels, so maybe that's still fine. I could try and calculate good values for these, but I feel like it's ultimately about how it feels anyway, so I'm just going to run it and tweak stuff after the fact. First of all, I kind of want you to not be rotated. Cool. Oh, okay. These have still got their old values here since they were initially created before I have updated those. You know what, because of the perspective I can't even tell which way this is rotated. Okay, yeah, this is the opposite way around to what I want, I believe. I was going to try and show with my hand what I expected to happen, but with the camera being flipped and stuff, it's going to... Okay, that seems correct to me. Yeah. Okay. Make this much higher. I feel like this needs also to start like resettling itself and kind of resetting. So yeah, I may switch out of the graphic in that case. It's kind of a handy trick to apply like a smooth reset. I just multiply it by some fraction. It's kind of frame rate dependent, so it's not perfect, but it will probably do for now. It should do this regardless of whether I'm dragging it right now or not. Which means that this stuff shouldn't return, which means I should probably move this to another function. Just throw this in. Yeah, so I want it to like settle. Okay, so if you look here, we can see that it is getting rotated and then it's kind of settling back. The settling is probably way too slow. This is probably just way too subtle overall. So I think what I'll do is just knock that down a bit. Okay, it's probably hard to tell. I don't know if the frame rate of the stream helps. I can see this is kind of doing what I want. Might just make this way more extreme. No, I think what I'll do is I'll change how this decay works, so it's less of like a non-linear thing. variable for this. Kind of confusing myself here. Okay. Okay, that's a bit more explicit. Boom. Oh, hello. Hey Fano, how's it going? Didn't expect to see you here. Yeah, so we're just playing around in Unity. What we're trying to make is some Hearthstone style cards. So right now I'm working on the... Okay, I've just been linked to video. Good stuff, thank you. Staying alive, aren't we all? Most of us, thankfully. Okay, so now I've got a bit of these draggable cards where I can like move them around and they'll kind of rotate in accordance to my... It's kind of subtle, I don't know if it's worth spending all this time on, but they'll kind of rotate in accordance to my dragging and settle back down, so there's a bit of liveliness to them. It's good you're here. You probably spend more time than I do on Unity these days, so sure you can help me out with this. Okay, so we got the basic draggable card thing happening. You can play around and make these feel nicer, but for now this will do. What I really want to focus on is actually getting into some of the shiny like visual effects and maybe playing around with some shader code to make these things look more awesome. No, it's not. So, I mean, maybe one day. We do actually use Unity for like as an editor for certain things, but we then export them into the game. This is kind of just a pure side project, fun throwaway thing that I'm doing, kind of just for this stream, more or less. Yeah. So let's start thinking about like the visual effects of these cards, right? So I think there's two sides to it. So there's the we've got like the overlay already, and the effect I want to add to that is like a kind of glowy, glinting effect on these nice like gold filigreed pieces. And I think once that's done, we can get into some of the more dynamic stuff and animated stuff happening inside here. Bracky kind of tutorial. Yeah, so I don't know if it's Bracky, but I saw somebody talking about Hearthstone effects. Scriptable objects. Okay. Interesting. Yeah, this is not anything to do with gameplay. I don't know if that's like a gameplay related thing. This is purely like the visual aesthetic of these things and having you know, this kind of stuff going on. That's what I'm playing around with at the moment. Yeah, I do remember seeing something relating to this which kind of inspired it. Yeah, but it's kind of just for the fun of it, really. So I feel like what I want to do, if I want to apply an effect to these filigree parts, I first need to like mask these out somehow. I think an easy enough way to do that. So if I create a copy of this, I'm going to call this how you spell filigree. It will have to do. Okay, I can do some like leveling stuff to try and like cut out the non-shiny segments of this. Preview would be good. So I'm trying to isolate those gold pieces. Probably bump those up. Maybe I'll manually just paint out some of these artifacts here. Yeah, so we're kind of missing some of these bits, but I think that's probably okay. Because what I'll probably do is turn this into grayscale. Whoa. Okay, it's trying to do dithering. I do not want that. Saturate this right down. Okay, so I think this gives me the mask for some of those effects. I don't know if I'll need alpha as well. We shall see. Let me export this. Cool. So now we get into the scary territory of shaders. I should qualify this, by the way, by saying that I'm by no means an expert like shader coder. I've done it a few times. I've like modeled through and created shaders where I've needed to and implemented effects that I've read about on stuff, but I'm not like a super experienced shader coder who remembers all of the syntax and functions and keywords and stuff. So this is kind of going to be modeling through. If anyone has any tips or wants to like backseat code here, I really do not mind. I feel like the unlit shader probably the best starting point. Okay, this is where things get slightly scary. So we have our main texture. I know I'm also going to need the filigree texture here. Okay, I'm going to Google how to spell filigree because I'm not 100% confident. Okay, and I'm kind of talking about the right thing. Okay, had a moment of self-doubt there. So want opaque, we actually want this to be transparent probably. So, well, first of all, I'm going to apply this to the card overlay material. So we're going to use this custom shader. Ooh. Okay, so I think what we're seeing here is, yeah, so this image had an alpha channel, but in images with alpha channel they also have image data still, even for the transparent pixels. So whoever made this card, this is just what happened to be in the image, but like masked out and transparent. So obviously the transparency is not being applied in our shader here. So I need to make, so I don't need fogs. Okay, first I'm going to trim out some of the craft stuff, which I feel like is not necessary. This is going to be a very simple shader. Don't care about any of this fog stuff. Recompile this. Transparent. Okay, Google to the rescue. So there's some flags we need to set to make sure that the alpha and stuff is applied. Okay, this would make sense. Okay, so Z write off is saying we don't want to write to the Z buffer. It's kind of out of scope to talk about, I suppose, but generally speaking, you would render fully opaque objects in one pass and then transparent objects after that. But because partial transparent objects have like partial transparency, you don't want them to like obscure things behind their transparent part, so you don't write to the Z buffer. If anyone wants me to go into this, I can do that, but it's kind of tangential for now. We just accept that we kind of need to do this, I think. Then the blend mode is going to say, this is what says when we draw this over something. We draw our new image with the intensity of the alpha, and then 1 minus source alpha. So if we're at like 25% opacity here, then whatever's behind gets drawn with like 75%. So those add up to 1, and that's what kind of blends those layers on top of one another. But, you know, as I say, we can probably just take it as a given that this is what we need to do for this kind of shader. This is what I say when, you know, I'm not like, you know, I vaguely understand what this stuff all does, but I'm not like a super pro shader coder or anything. Okay, we're getting some transparency applied. That looks good to me. Now that we have this material though, we can put our filigree texture in here, and we can start doing something with it, right? I suppose the question is, what the hell do we actually want to do with this? Okay, I feel like what we kind of maybe want to do is something related to the angle of the card. Because what you typically see with these effects is like you'll get like bands of glowiness, right? Like as it's kind of rotated, the light will like catch this area, and then any gold bits in that area will get like accentuated somehow. And similarly, like maybe it's like this. So we need to do something to do with the angle of the card. Will cause a different like section of the card to be like highlighted, but we'll only be highlighting the filigreed parts of the card, something like that. So it's kind of a geometrical thing. The thing that makes this kind of weird is that the card is actually flat, so like in normal physicsy terms, right, if we have our card like this and we have like a directional light coming in. Oh, lost my color. Have like a directional light coming in like this, like rays. Then typically when you're thinking of graphics, right, this whole surface is at the same angle, so you know, the rays are all gonna like affect it the same. But in order to get this like stripy effect, I'm sure there's a real physical formula behind it, but my first thought is, okay, can we like think of the card as like being slightly domed so that the bit which is more like front on to the light, like if you see here, it's kind of fairly directly hitting that, whereas this bit, it's more of like a glancing blow. So we can use kind of create like a pseudo curve to this thing so that it kind of like attracts or reacts to the light differently at different points along its face. This is like a top-down view, by the way, so we'd get like a card like this, so because the light's more directly hitting it on the left, we'd get like a banding or a highlight like here somewhere, but as the card, if it were to rotate like over here, then maybe that band is now like in the middle. I don't know if this makes sense. This is, I think, kind of what I want to do. So ultimately what we want to figure out is geometry-wise, we need to sort of consider this curve, right? So probably what that means is, so we need a light angle to begin with, and that can probably be like a fixed thing. I mean, we could actually set up lights in the scene and do it based on that, but I can maybe just have like a fixed like vector which we pass in, which determines this angle, and then when we're looking at pixels in the middle of this card, we're going to consider it like flat. Whereas if we're looking at pixels here, we'll consider them like, you know, like at an angle. If we're considering them here, they'll be like at less of a steep of an angle. So this is kind of how it's going to react to the light, I think. And I think that will give us the effect that I want, because even though the card's flat, these angles would suggest that it's got like, you know, some curve like this going on. It's not like a physically accurate thing, but I think it will allow us to get that effect, probably. So we have a bit of some inputs to this which we can already play around with. So we have our, when you're in a shader, the main thing you have to deal with is like UV coordinates, right? So we have our card, and U is equivalent to like X, and then V is equivalent to Y. I forget if it starts at the bottom or the top. I could probably verify that, but right now I think we're talking about U, right? So this would be U of 0, this would be U of 1, this would be U of 0.5. So when U is 0.5, we're going to sort of work out the angle between like this vector and like a flat thing here, whereas if U is 0, we can probably have a parameter which says like how curvy is this, like is this like, you know, 45 degrees or like 90 degrees or some more like shallow angle, and we can just sort of interpolate between those, right? So yeah, so right here now it's going to be 0, now it's going to be like minus max angle, whatever we call it. Over here it's like max angle. Yeah. So another kind of handy thing I find to do when coding shaders is to just do some debug rendering type stuff. So let's make some parameters. I've also forgotten the exact syntax for this stuff. So Also forget the exact syntax, so it's been a long time since I've written a shader, so to define these kind of uniforms. Okay, just like that. Yeah. So what we kind of want to do is interpolate between like one angle on one side and the other angle on the other one, such that they kind of have 0 when they're in the middle. So I believe it will be light between A and B with a ratio of V. So all we can kind of do here is light between negative of X. Okay, so we have this angle. It's going to start at like minus something and then extend to plus something. So I kind of like to visualize this. So maybe I'll just do that with the color. Did not like that. Maybe I need to do aha. Not sure what's going on here. Okay, yeah, it's this subscript I don't like. I always forget how they have these swizzle things on these. So there's loads of different ways you can index and slice them. I always forget. Okay. So I think this is doing what we expect. Yeah, so we're getting kind of the this sort of pseudo angle thing defined, which I believe does what we want. So now I think we also want to be able to pass in a vector for the light angle. Again, I forget the syntax for this. Vector is at 4D by default. I guess that's fine. 4 numbers, okay. Cool. So we have this vector, which is going to define this direction here, which we were talking about. So now what we need to find is, okay, so now we know this sort of angle which we're thinking about. We know the angle of the vector. So what I now need to calculate is the angle between these two things. So basically whether they're like head on or whether they're like at 90 degrees to each other. So yeah, the dot product is what does this for us essentially. It will take two vectors and kind of give you a number which represents how similar they are. Yeah, that's true. Yeah, it will kind of tie into that, I think. Vectors. Hey, Macinario, welcome. So, yeah, okay, I'll give you a quick update because my brain needs a little break about what we're trying to do today. So we're trying to replicate some of the cool effects you see in Hearthstone cards. So some of the glowy, some of the nice glowy stuff. Some of these, maybe even some of these like misty, particle-y animated effects inside the cards themselves. So I think they're pretty neat. What we've got set up right now is we have a kind of card set up for our engineer character. We have these set up in the... Okay, you probably can't see that right now. We have these set up in the game, and they're set up so that we can... So we're using Unity to do it this time. We have these set up so that we can kind of drag them around. Yeah, it may not be super obvious to see, but the cards are like tilting in relation to the thing. Yeah, right. So right now we have two layers. We have like the main card and we have the content. I think the way Hearthstone does it is they have like several optional effect layers. Like they have a distortion effect. They have like a overlay texture effect, which can like scroll around and stuff like that. Like this, right? Like this kind of thing, or yeah, like this background thing. So they have like a texture which just scrolls like the UV coordinates, and I think most of the cards are made with a fairly minimal set of different effects. They're just put together in clever ways. Yeah. Golden to non-golden. Yeah, I suppose it's mostly the golden card effects which I'm looking at, I suppose. So we also played Monster Train recently in a stream. So we did a little Stray Basilisk game night stream where we played Monster Train, which is another... The aesthetic is very Hearthstone-like, and they have some similar cool card stuff going on. No, they're not. They're like... These are like dynamically done with shaders and textures and stuff, so... Yeah, these are not like animations which are baked in. These are all like dynamic effects, like built up in layers with a toolkit of certain different effects which they can like creatively like combine together. Yeah, it's kind of amazing, like art style wise, like what they were able to pull off with that. Yeah, so okay, so what we're trying to work out now is we need the kind of normal of our surface. Which I guess is probably in our vertex, right? I bet there's a predefined thing for normal we can use. Cool, I think this will do what we need. It's included already. Oh. Cool. So now we could probably just... So we now have the normal of this face. Oh, where are we? Which will effectively give us like this direction here. And then all we need to do is compare it against the light and then kind of tweak it up by this kind of pseudo curve type fake normal thing which we've introduced. So let's ignore that pseudo angle just for now. and I think I'm correct with my swizzly stuff here. So this vector which passes in is actually 4-dimensional. We only care about like the 3D XYZ of it. Oh, I need to make sure it's declared down here. Okay, that's fine. So, okay, so we now have basic inputs we need. We now have like this angle here. We have the angle of the light, which we just sort of passed in as like a global thing. Now to calculate the angle between them, we can use the dot product. Oh, we should make sure that these vectors are normalized though. So this needs to be a unit vector, meaning it needs to have a length of 1, otherwise things will get skewed off. A normal is kind of, I think it's assumed to be a length of 1 sort of anyway. Okay, yeah, so in a shader, I'm not a super... Yeah, so this is kind of weird, right? Like shaders are funky because it's the interaction between like the graphics card and the CPU. So these properties, or I guess you'd call them uniforms more generally, these are what the CPU passes into the graphics card. It gives it a texture, it gives it some other texture, it gives it some parameters in here, this case like how bendy this card is going to be, and also what direction like the light hitting it is coming from. So, you know, it's fairly normal that you pass in a texture, but you can pretty much pass in whatever other information you want. So this is like the interface between my normal Unity code and the code, this code here, which is actually going to run on the graphics card. So that's why it's somewhat archaic. And the way that this works is there are 2 stages. The first one is a vertex shader. What this does is it takes the points of the object, like the triangles the object's made of, it sort of transforms them according to the camera perspective and stuff, and then it works out sort of on screen where those things are going to be. So that sort of handles the geometry. And what we're doing here is we're taking the opportunity to figure out some other stuff along the way based on that. In our case, we need to know what direction this face of the card is facing in the world, so we can work out if it's like the light is directly hitting it or kind of hitting it at an angle. So you can kind of tag it with some extra information here. And then the final stage is the fragment shader, which is basically, it's not quite true, but it more or less is running for every single pixel which you're going to draw. And that's where you like look up into the texture. Okay, the image of our card is this color at this particular point, and we're going to sort of affect that by the light and other stuff. So yeah, it's about all of these interfaces. I don't know if they need to have an underscore, but it's 100% is a convention, because these are like the inputs to the shader, and this is the interface between this and like the outside world. So yeah, so the dot product between 2 vectors is more or less, I can find a better diagram of this. This is very common in like lighting calculations, because lighting is more or less based on whether the light is like directly hitting something or hitting it at an angle. And a dot product is a key thing in that, because it kind of tells you it's proportional to the angle between, right? Or like the, I guess, the cosine of the angle between. Yeah, whereby if they're pointing in exactly the same direction, I believe it's 1. If they're at 90 degrees, it is then 0. And if they're pointing in directly opposite directions, then it's -1. I think that's right. So if we have our card surface and it's facing sort of this way, and then the light is hitting it this way, then the light's hitting it directly if the dot product is -1, essentially, I believe. In fact, what I can do is just... so we have that dot product. I can do something like... I can just color this by... So I know this ranges from -1 to... So we want to make this... with light makes more sense, maybe. So we're going to map this now to the range 0 to 1, and then I'm just going to color the red component of this with that. So blue will be 0, or green will be 0, blue will be 0, alpha will be 1. So this will kind of allow us to visualize what's going on behind the scenes. So we should probably give... Okay, let's make it so that... Okay. So this light unit vector I put in here is kind of now... so this is the z-axis here, right? So it's now... I've probably got something flipped around. Okay, but I think now if I rotate this card, we should see that the light is sort of fully... Okay, let's stop playing. I'll rotate this card. It's now like a mid red. If I then rotate it that way, it's now gone black. Okay, so we're kind of getting what we expect, right? Like if the light is directly hitting it, we're showing this full kind of value. It's like yeah, in this case the dot product is 1 because the direction of the light, which is actually negative z, is actually this way. So the normal of this surface is pointing this way. The light is also pointing this way. So the dot product is 1. So this is like 1 as in like full redness. Whereas if they're pointing in directly opposite directions, or actually the same, then the dot product is 0 or -1, and we've mapped that back to 0. Okay, and this is like halfway between. So I believe this is doing what we kind of need it to do. I'm not sure if I'm super coherent here. So I feel like I want the actual direction of the light to be makes sense for it to be, it is 1, so the light is like pointing into the scene, like along this way like this, or maybe I could do like a 45-degree thing. I don't know, this will do for now. No, so I could have used the light object. I'm actually not using that. I've just sort of manually defined the coordinates, or rather the direction of the light. Yeah, so there is no object for the light. What I could have done is placed the light and then used that as a lookup, and you know that probably would have been smart to do. But for now, just to sort of debug it, this kind of works for me. So okay. So we now have this dot product. So -1 is kind of direct lighting. Right, so I think I can just modulate this by our kind of pseudo angle. Actually, you know what, let me first just, I'm going to what do I want to do? Okay, so if it's like -1, I want to have it lit. If it's less than, if it's more than 0, then it's actually going to be facing away from us and we wouldn't even see it anyway. So probably doesn't matter what we do. So like this. And then what I think I'll do is I will, this is our main texture color. Just going to kind of multiply this by the intensity of the light. I'll just use the actual alpha from the main texture as it is. Cool, didn't throw an error there. But now if I take one of these cards, as I rotate it, okay, cool. We can see that when it's directly facing forwards, we're seeing like full color version of this. If I turn it so that kind of no light would hit it, then it gets, it's, the card outline is now kind of fully dark. If I turn it back around here, I think we'll just see black still. Yeah, it's like actually got like negative color values, but it doesn't matter because we can't see it anyway. So now we can see that this thing is like sensitive to the angle. I could go into this material now and I could change this so that it's, okay, this isn't going to be exactly correct mathematically, that's not a unit vector. But now the light is coming in at sort of 45 degrees, so we can see it's like fully bright here and then it starts to get darker as we change the angle here. So all I wanted to do then is put this back to put this like pseudo angle thing into play, where we sort of offset that. By this pseudo angle. I think this will make some sense. Nope. Okay, you don't tag floats with F in shader. Okay, so that's fully right. In fact, that's like twice. Okay, that's not quite what I wanted. So this is -1. Scale that back down to normal. We have our cards here. So if I then tweak the material here, Okay, it's kind of giving us that effect. So I can see now that as I rotate this, I've probably got something backwards. Okay, I feel like I need to think about this mapping a bit more intelligently. Let's clear out some of this stuff. So we have our kind of card surface. We have our real card surface. We know that. So we have the normal of this card. It's kind of like this. We have the normal of the light, which right now is coming in kind of straight. So we know that in this situation, we're going to have like a -1. Here it's going to be like minus 0.5 or something, whatever it may be. Hmm. Okay, so in fact we don't want this to be like minus 0.5 to 0.5 because it's kind of symmetrical. And we're looking at the offset from -1. So this is -1. Okay. Right, so if we're straight on, then it's -1. If we're like not hitting it at all, then it's 0. Yeah, you can tell I don't spend a lot of time writing shaders. This is not my strong suit. I'm muddling through this. I feel like we're close to getting this effect to work. So in this case it would be 1. What we want to do is map -1 to 1 and this to 0. Okay. So it's kind of actually just going to be negative that. Okay, there we go. So if I put this at 0, we can see that we're seeing stuff in the center, so there's like a central band here where there's like this highlight happening. And as I rotate this card, that is not going anywhere. Okay, what's wrong there? Oh, you know what? Yeah, this is not going to work. Yeah, so we're getting that like middle streak, but it's not quite doing what we need. I kind of need to actually rotate this normal, I think. I'm sure there's some handy functions for this. I'm sure there's a nicer way to make this happen. Yeah, right, I feel like doing some big matrix operation is not going to be the cleanest way to make this happen. If anyone has any suggestions, I am fully open to that. Yeah, I think this would probably do what we need. We want to rotate around the kind of the y-axis, I believe. Okay. So if it's not clear, and I'm sure it's not, what I'm trying to do is actually this effect here to figure out the effective like normal of this surface. I kind of want to rotate around like this point, right? So that this normal can be rotated to, you know, like this direction and so on. Because that will allow me to properly calculate the angle, you know, how this angle from the light and this angle from the surface kind of interact. So I kind of need to rotate around a particular axis to do that. Oh, you know what? I could maybe do that here and have that interpolated. No, it needs to be okay. So this is kind of what we need here. Okay. Okay, what have I missed here? Oh, these were half, weren't they? So let's make these float. Ah, okay. I got these wrong way around. Okay. So what's the issue here? Probably something stupid. Probably overlooking something super obvious here. It's the thing as well with like editing shaders, I don't have a great editor which lets me check the types of all of these things. Yeah, so what I'm multiplying a 3x3 matrix by a 3-element vector, which I believe should give me a vector, right? If you multiply a... Yeah, if you multiply a matrix by a vector, then the result is a vector. Maybe that's the way around. Yeah, it's... Well, this matrix math is weird, right? This is like the... Again, not my like super strong point. I like model through this stuff and then I hide it away in some code that I don't have to worry about too much. But it's important, you know, shaders are all about matrices and normals and that kind of thing, and it gets pretty deep. What is the type? Ah, okay. Maybe I should be using something else to do this? Okay. So it expects matrix and then a vector. How's that? Okay. Something's happening now. No longer need to do this. Maybe tweak that material. Yes, we have cracked it, I think. Okay. So let's see how I'm able to like define this band in the middle, and then I believe I may have my rotation the wrong way around, but I believe if I rotate this thing, okay, the highlight's moving the wrong way, but we can fix that easily. I should also, I can just normalize everything here. I may as well do that. I can just normalize the light vector. Maybe not super efficient, but a bit more robust, I think. Or I've just busted things. Oh, I bet it's lost the parameter since I renamed it. Okay, I believe this is doing what we expect. So rather than hitting direct, even though this card's flat, it's as if it's curved, right? Because if the light's coming directly sort of from our camera now, and I rotate this thing, actually let me go back to this view. Yeah, you see that only the middle band is kind of lit, but as I rotate it this way, the light then begins to catch this side. So it's as if it's like pretty curved, because this thing is fully lit like here, so it's almost like a 45-degree curve in this thing, but we can tweak that down. something like this. So now we should still have that same effect, where this side like catches the light more as it's rotated, then the middle catches it, and then the side catches it. Okay, so we've now got this differential thing, which will allow us to have the shiny effects not just be flat across the surface of the card. But what I really want to do is, I don't want the card to get like dark. I want these to get like especially bright. So I think a simple way to do that is to do something like simply add 1 to it, right? So it gets super bright and like kind of oversaturated. The problem is that affects the whole thing. I then want to only do that to the gold filigree bit, right? So we've got this mask texture which we created, which kind of demarcates like which bits are to be like filigreed up or not. So I kind of want to use this to apply this effect selectively only to certain pieces. So what I'm going to do is so one is like the base texture, which we'll always see, and then I'm going to add this isn't light so much, this is like the filigree glint intensity. So I'm going to do this, but then I'm going to scale that by a value from the filigree texture, if that makes sense. So I'm going to sample that filigree texture. And then I'm going to scale it by... Okay, so right now this is just like a black and white texture. So, you know, if you look at like a white or a mid-gray value somewhere, then the red, green, and blue are all the same. So I could just look at the red, and that would tell me sort of how white or black it is, right? This also means we could pack other information into the same texture. So, you know, we could use the red to indicate the filigree, the green to indicate some other part which has some other different effect applied. Hopefully that makes sense. But that's very common to do in like this shader stuff, is that you will pack different bits of information, which could be thought of as like black and white images, into the red, green, blue, and alpha channels of a texture to be more efficient with memory. As it is right now, there's only like one channel of information that we care about. So I can just look at the red, all the green, all the blue, like either would have worked to pull that out. So this should then cause an error, apparently. Okay, so I think we have more or less a complete effect. Okay, this is kind of subtle. Maybe what I will do is drop this down a bit so it stands out a bit more. I could make this just super high, just so this is like super obvious. Okay, we're kind of seeing the effect a bit more clearly when it's like super exaggerated. So as I kind of move this into the light, you see the filigree on this side like really catches the light here. It kind of moves across the middle and then off into that side. So maybe I actually want like a parameter for like the filigree intensity. I don't know, like 3 or something. We also have another parameter here, which is like the kind of like the ambient lighting or like the base light. Okay, now hopefully this makes a bit more sense, like what's going on. This is the key line here, right? Like we work out a lot of stuff using some math, but the intensity of the color in the texture is equal to whatever that base light is, plus we sort of overlay the filigree back on top. So this ratio is based on the camera angle, so how directly in the light it is. This is the mask, which masks out filigree pixels versus like non-filigree pixels. And then this again is just like a tunable parameter for how intense that filigree effect is. So I think with these in some combination, we can start doing something here and sort of tweaking this so it's like aesthetically pleasing. First rotate this back to the middle. So the more I curve this, the more directionally sensitive this sort of effect is. So that's probably too much, so we can drop this down until it's clearly like catching the middle but not the edges. We can bump up that intensity of that glint or pull that back down. We can make the base texture appear like brighter. Oh, that's not doing anything. Okay, so we can make it... Okay. Okay, I feel like we've really got something here now with this effect. So we can see the filigree. There we go, that's nice. That's what I've been looking for this whole goddamn time. So it kind of also accounts for being at a different angle, I suppose. Yeah. A lot of work for like a simple effect, but okay, this is the beginnings of something, right? Like it feels realistic. It feels like there's actually a shiny thing going on here, which is kind of what I was after. Oh, okay, I think what's happening sometimes is the filigree is getting like below 0, so I should probably like clamp that so it can never get... So it can never get out of the like 0 to 1 range. Boom, okay, yeah. Nice. I'm sure we could tweak things to like okay, I'll go back to the main view and press play. Yeah, it's not super apparent still, like the angles are a bit not extreme enough, so maybe I can even tweak this so it's more apparent here. Orthographic, yeah. Okay, so one thing is that what I'm kind of using this to like determine how wide the glint is, right? But that also means the narrower I make the glint, and therefore the more like pronounced the effect. It's also like the further I have to rotate the card for it to like have any seeming effect. So maybe what I want to do is something like if I make this actually fairly narrow, but then I do like then I like square the effect, which will make it tighter without making it more or less like sensitive to angles, if that makes sense. Yeah, because when I push this up to like make the glint narrow, I'm effectively like curving the card around, so it's like really curved, like conceptually. Which means I have to rotate it more, which means this little movement is not like super consequential in terms of like moving the glint from side to side. So I want to be able to separate out the tightness of the glint, I think, from the angle sensitivity. So I think what I'll do is, do we call this like attenuation? I don't know. I feel like that's the right word, but I'm kind of clutching at straws. Attenuation. Yeah, right, it's like making it sharper. I feel like that's maybe the correct term. And what I'm going to do is I will just apply a power to this. So if it would be like 0.5 at the edges and like 1 in the middle, and I square it, then it becomes 0.25 at the edges, but still 1 in the middle, so it makes it more dramatic, if that makes sense. A whole load of parameters here, maybe more than necessary. Okay, which should mean, hopefully, that if I increase this, yeah, cool. Whoa, yeah, below 0 we get some super weird effects, but I can effectively narrow this glint, which means that I can make it less like curved, but more attenuated, which means I've made the glint narrow, but presumably less sensitive to changes in angle. Yeah, I feel like this is something I kind of needed. And that's quite a big angle. So we know this thing moves like up to maybe 20 degrees, so I kind of want to make it pretty prominent at like 10 degrees. So Let me do this to put it to the side. The attenuation. Something like this. So now if I rotate this thing, yeah, it's much more like angle sensitive. Which means that now, okay, we can, yeah, it's kind of fast, but we can actually see the like angle of this glint effect like changing as I drag the thing around. So it's not totally static. Okay, I think this is a good point for a break, and then I'll maybe come back and try and apply. I feel like this is the hardest part because it's involved a bit of like geometry stuff, which I'm like, you know, somewhat familiar with, but not. I knew what I wanted to do, but in terms of the syntax and doing it in a shader, that's not my everyday kind of thing. But what we're doing next is a lot more standard probably, and a lot less complex, and it's going to be some like glowiness or distortion effects over this engineer itself, which I believe should be a wee bit more straightforward to do. Okay, so I will take a short break and I'll be back shortly. Okay, we are back. Here's where we're at so far. So we've got this kind of nice card effect going on. We have our engineer mounted into this card frame here. The main thing we've been doing so far is this kind of glinty effect. So if you watch the kind of gold filigree around here, it kind of responds to the light and the angle to create this kind of gold glinting card effect. So what I'm going to do, as is kind of customary, is kind of walk through at the halfway point. Actually, I feel like we're more than halfway through at this point. The first section was kind of long, so I kind of walk through how this is structured right now. So doing this in Unity, we only have one script which handles the dragging this character around. Pretty much all it does is when you press the mouse, it will do a kind of recast to figure out if the mouse is over this particular card. If it is, it will pick it up and it will remember the mouse position and the card position when the drag action kind of began. No longer need to log out boom, I don't think. Then what it will do is, like, while the drag is ongoing, it will just work out how far the mouse has moved since the start of the drag, and it will move the card correspondingly. What it will also do is apply a bit of rotation to the card based on how far it's moved. I feel like this could be improved a bit, but for now we have something basic going on. That's pretty much all the movement is. It's just a basic like click and drag thing with a little bit of slight fanciness on top of the angle stuff. Where the real meat of this is, of course, is in the shader. Ooh. Creatix is racking up the points. Okay. 2D city map drawing tool similar to Townscaper. Okay, you spent the points, let's find out what Townscaper is. This looks really cool, right? I've been looking at the GIFs. They've been killing it on the GIF game. It does look really nice. Okay, 2D map drawing tool. So you're talking about like a fantasy map kind of thing, maybe? I think there was a... town map generator. This is the one, I think. I don't know if you've ever seen this. Oh, this is improved since I last saw it. But you can just click this and I mean, this is more than like 3 or 4 hours work, without a shadow of a doubt, but this is very cool. Yeah. Is this the kind of thing where you're picturing, or are we picturing more of a... like a grid? This is ultimately like a grid-based thing, is it? Am I right in thinking? Maybe not. I maybe need to look into more how this works. But it's like building components, taking components and like connecting them up together. This could be cool. yeah, if you have any more thoughts about the details of like what this could look like, would it be like a front-on thing? So you're looking at like the fronts of buildings like this. Would it be like a top-down thing where you're placing down blocks, city blocks, and stuff like that? But yeah, that'll be on the Twitter poll next Thursday, and probably it's a good idea. I like it, so I'll probably leave it there until someone picks it, or until the people pick it, I suppose. Cool. We can now forget about this horrible matrix math. Speaking of that, I'm kind of going to go over it now. So right now, the only effects we've got going on are on the like outer layer of the card. I should probably mention, in fact, that the card has like an overlay as well as the actual content of the card. So far we've written a custom shader for the overlay, and this is probably super inefficient and there's way too many parameters, but I kind of wanted to tweak the visual effect. What it does is you give it a basic texture, which is, you know, this thing here, the actual image it's going to display, and then you give it this filigree mask, which is like a black and white thing which shows where the like gold leafy parts are, I suppose. Because we only want to apply this effect on the kind of gold leaf parts. And what we do is we imagine that the card, because we don't want this glint to apply over the whole face of the card, we imagine that the card is kind of curved. So that even though it's really flat, what we're going to say is if the light's coming in like at the edge of the card, it's actually going to act as if it has like a curved surface, so that we get like a band of glinting as opposed to like a flat surface which all reacts, you know, a perfectly flat surface reacts to light like kind of uniformly, and we don't want to do that. So what we do is we kind of fundamentally, the way you work out how much direct lighting something's receiving is the angle between the incoming light and the like surface. This is what we call the normal of the surface, like the line which is at 90 degrees to the surface. So we basically fake that further to the edge of the card, the normals get like rotated outwards. And that's ultimately what we landed on here. Then we kind of rotated this normal, then we like calculate it's not really the angle, it's kind of proportional to the angle. That's effectively what this does. For this mask texture, I'm actually going to call this mask texture because that's really what it is. It's not really the filigree itself, it's kind of its mask. Okay, so looking at creating suggestions. So you kind of define a shape and it would like fill it with stuff. Yeah, I'd need to diagram that out. Yeah, we'll think about that. That's a cool idea. Yeah. I think with that web-based thing as well. I think you could like drag bits around or something. this warp? Yeah, right. So there's clearly some underlying like mesh. It actually gives a quite indication to how this is implemented, right? There's like a mesh of points here, and if I move this, it's then just like tessellating stuff into here. So it's probably doing something like dividing it up into triangles, and then there's some routine for like recursively breaking down these areas or something. It's very cool though, like, and there's probably a lot of tweaking to get it to look aesthetically good. But yeah, it's really impressive, to be honest. Cool. I will think about that on the back burner. Okay, back to this. So we have this mask texture. So then we know what the kind of angle is in relation to the light. And then we sort of calculate the final intensity by overlaying more or less something like that. Yeah, so all we're ultimately doing is making the texture more or less intense. So the whole texture gets this like base lighting amount, and then this filigree intensity is kind of like some extra lighting which is applied to just the filigree bits, and it can actually be... Whoa, okay, I probably need to tweak the parameters again. It probably can be like pushed over like greater than 1, if that makes sense. Cool, but these look pretty awesome and shiny and metallic and stuff. So the next thing is I want to apply at least one effect to the body of the card itself, and I want to pick something which is relatively easier to do. So I think what I'm going to do is a distortion field, if that makes sense. So similarly to the other. Hey, Fano, take care, man. Maybe I'll see you around someday soon. Cool. So what I kind of want to do is apply a bit of wobbly distortion to probably just these like areas around the heated sections. And conceptually kind of how that's going to work, I think, is within these sections we're going to be like effectively like kind of randomly like nudging pixels around and sampling from slightly differently positioned pixels. Oh, cool. Thanks, Tom. Take care, man. Yeah, so I'm going to create a mask for this because we only need to apply this to a certain sort of area. So I'm going to kind of mask out his really... Tell you what I do, I'll take these bits, I will kind of clip them out like this. Somewhat roughly for now. I'm pretty certain this exact effect is the one that I've seen on real Hearthstone cards, what I'm sort of planning here. Okay, then I'm going to kind of fill these in white, and then probably kind of want to get a bit of blurriness going, so I'm going to create another copy of this which is blurred lightly. That looks kind of good. So I'm going to blur those central bits. I don't want them to be totally sharp. Also this kind of area over his shoulder, I feel like that needs some love as well. So maybe I just... Oh, maybe not quite like that. leaked something. You weren't supposed to see that. Cool. I mean, we can tweak this mask later, but more or less this is the effect that I want. This will show us the areas we want to apply distortion to. Maybe I'll also widen these out a little bit. Oh, what's going on here? Oh, hang on. Let's move this out a bit more. Okay, this will do. This kind of gives us the mask we need. So, kind of conceptually what I want to do here is, so let me copy this and get our main texture back as well. Okay. So we have our kind of engineer, and we also have this like mask over the top. What I want to do is when I'm drawing a pixel, rather than drawing like this pixel, I kind of want to draw a pixel from somewhere near it with a bit of randomness involved, and that will effectively create like a wavering, wobbly, distorted effect. And I want the amount of distortion, which you can think of as how far away from myself should I consider, right? If there's no distortion going on in this pixel, then it needs to be that pixel in particular that it kind of draws. Oh, why can't I? Yeah. Oh. Whereas these pixels, which are like right in the fire and like the intense white part, they're going to look further afield for the pixel to kind of sample from, which will mean that they like wobble and distort more. Something down here won't really do it at all. So I need to now create a bit of shading code to do this. I think I can do this relatively quickly. It's something I'm a bit more familiar with. So I'm going to copy and paste this. Give it a new name. Well, I suppose it's just the card content, right? Because all the effects I'm just going to shove into this one shader, more or less. So here's the main texture. We're going to have this distortion mask. And then maybe it makes sense to have a distortion intensity. We can tweak that. I don't know if we need any of this other stuff right now. Should be fine as is. This normal junk, we don't care about it in this context. I don't think we're having like shiny stuff within like the window, the little portal into the engineer's world that is affected by the angle. So we probably don't need this normal stuff here. Is that even doing anything? Oh. To be honest, I'm not entirely sure why this is required. So we have the distortion masks. have the distortion intensity. Don't need any of this junk, so what we're effectively going to be doing is, rather than sampling from this UV coordinate, we're going to be offsetting it based on the distortion mask and also based on some random factor, which I would like to do with noise, like a noise field. So for now, let's just do it sort of intensity is going to be take that. Distortion intensity is just going to be equal to, for example, the red component of this. Again, it's black and white. We're not packing a load of stuff into one texture, so that will do. That's fine. What we can ultimately do is make this a general purpose mask texture for like several effects and use red channel for one, green for another, blue for another, alpha for another. Have to rename stuff, but for now, this should work for us. So what I kind of want now is to create like a distortion offset, right? Ultimately this is going to be based on randomness, but I think for now I'll just do something like this. So it's going to be kind of offset by looking at stuff to its right, and this is what we'll replace with something a bit more organic and maybe changing over time later. So then I can add to this that offset. And I could just return this, but we may sample something with like a different alpha value. I want the alpha to be I was thinking I should sample the original position without the offset in order to use its alpha. It may not be an issue if everything is like within the bounds of our card. Probably should do that to be more thorough. So we're going to use the red, green, and blue from the offset, but I'm going to use the alpha from the original non-distorted bit. Okay, probably got something wrong here. Let's check my compile errors. 955 does not like. Oh, should be float 2. So here we're creating a vector which just like points to the right, and then we're scaling it back by the mask value from this like pixel. Now I need to make an actual material from this, so the shader is going to be, oh, I should give it its own name. Use the card content shader. There's your image. There's our distortion mask. Okay, You can see this distortion is effectively just a texture scrolling effect at this point. Is it considering that mask? What I could do here. By way of debugging. Yeah, it appears to be going uniformly across, which is kind of weird. Text should be text. Oh. Probably help if I actually pass that in. Okay. Yeah, I think I fixed that bug by renaming it from text to text, but then I had to actually pass the texture in again. Doesn't like that. Okay. This is gonna look kind of weird, but I think that is actually to be expected. Whoa. That looks cool. Okay, you can see here, yeah, this number has to be kind of really small. But as I bump this up, you can see that it's kind of pulling. It's effectively being distorted in one direction or the other. So if I can apply some randomness to this, yeah, this kind of works, right? Because the fact that this has smooth edges means that we don't get a weird, like, clipped distortion. It appears to be smooth and kind of congruous, I suppose. But it's still, like, totally weird. So what we need to do is, rather than always be distorting left or right, we want to have a distortion based on probably perlin noise or something like that. So I'm hoping that there's a built-in noise function. If not, we'll probably have to pass in a texture. Yeah, this is kind of what we want. User noise texture, yeah, that's probably the way to do it, to be honest. You know what? Yeah, let's do it. Can I generate some noise here? Filters, render, noise, perlin noise. Okay. Oh, sure, this should be built in. Filters, render, noise, perlin noise. Let me. This does not look what I want. Scale. Try another kind of noise here. Maybe simplex noise. God, looks kind of weird. Not what I normally think of this noise as looking like. Do something like this, which is a bit more sensible. This needs to tile though. Don't know if it's going to do that for us by default. Nope. Pull something from Google. Let's find something which is... Oh. Well, there we go. Okay, this should do it for us. Put it into noise texture here, which I now need to pass in. So what I need is like an X and Y value like pulled from this texture, so I need to figure out I need to pick a random point on this, so what I need to do is get access to some kind of variable which gives us the amount of time which has passed. Cool. New of time.x. This should probably be a parameter to be honest, but let me just bit arbitrary, not the nicest way to do this, but that will probably do what we need. So we've got a random position in this noise texture. Now we need to convert that into an X and a Y value, essentially. So let's just take a couple of different positions from this. You know what, let's pick a non-even. Again, like super arbitrary, but probably a correct or somewhat correct way to do this, which is probably not this. You know what I could do? I could throw two different noise sources into this one texture. Right, so I could make this like the red channel. Add something else. I could make this the green channel. Yeah, this is probably a nicer way. I could add this on top. So now we've got two different noise patterns. Now we only need to sample the texture once. Okay, this works. So now I need to get an X and a Y from this, and I can get that easily enough by just saying, let's go that red, let's go that green. Now the distortion offset is going to be this offset from the noise times by the alpha from the mask. To factor in the intensity also. Cool. Now I believe if I play this, okay. They do this weird thing with time, which I suppose could be convenient, where they pack into a float time scale to different amounts. I suppose that's so you just don't have to multiply that yourself. Don't know where that originates, but I up the intensity here. Is this changing at all? I feel like time is not changing for some reason. Something else is going on here, so if I need to declare something else for this to be populated. No? Okay, probably maybe what's happening is that it's getting clamped to the edge of the texture. So it's getting to 1 like super fast. And no, set to repeat. Okay, so that's time definitely increasing over time. I haven't passed the noise thing into the texture, have I? Okay, there we go. Now we're actually seeing some noise. I should also don't want to select the same noise value for every pixel. Okay. Now if I press play, we're seeing our distortion changing over time. And now I can probably just drop this down to a sensible value. Oh yeah. got a directional bias. Okay, noise is always 0 to 1, so it's always going to go in one direction, so I need to center that back around around the 0 point, or it's going to be always in like the +1 kind of direction. If I do this, then it should be more wiggly. Wiggly is the word. I feel like another couple of parameters would make sense, like one being I should say like the rate of this wiggling, and the other one being like the resolution of it. So I feel like this noise texture could be like scaled bigger, and we could also like move over it more slowly, potentially. And you know, for different effects that might be appropriate. So just call it noise scale. For 1, and noise speed. What I need to do is pass those through. So if noise scale is large, yeah. Okay. So now if I make the scale bigger, yeah, it's more like chunky wobbliness. If I make the scale small, it's really like fine-grained, like, yep. This here so you can see it better. And the speed, I can also modulate this down until we get something that's kind of artistically pleasing, I suppose. Maybe the scale should be... I'm going for that sort of like heat hazy effect, I suppose. Yeah, but I think this is looking kind of nice now, to be honest. So if I flip back over, I can... switch over here, and then I can manually kind of rotate this thing around. Yeah, this is pretty nice. I'm kind of pleased with this. I managed to get, you know, one effect on the main card, and then one on the body of the thing itself. Yeah, maybe that's a good kind of medium for this guy. yeah, well, I'm pretty pleased with that. All things said, I think that's probably where we will leave it for today. We ultimately did what we set out to do. We can full screen this dude. I think we can call that a success. We have a Hearthstone-y, a pseudo Hearthstone-y card thing going on here. Yeah, the distortion looks really nice in the end, actually. Cool. Well, I will say thanks everyone who tuned in. I'm going to, as usual, drop a couple of useful links in here. So as Creatix has redeemed that reward to add something to the poll for the next topic, that will end up on our Twitter page. We normally do these on Thursdays. If you're more interested in the game that this character is from and want to check out more about Steamhounds, then our Discord is probably the best place to do that. Obviously, follow us on Twitch. We just hit affiliate last week, so that's cool. We're trying to figure out what we should do with the points. So, you know, any suggestions for like content or other shows or things to do with the points are always welcome. Yeah, but I think I will leave you with that. I banged my head against the wall a little bit with the shader and the matrix math, to be honest, but we figured it out at the end, and ultimately I think he looks kind of badass like that. Cool, okay, thanks everyone. I'll see you next time.